In this screencast, I'm going to talk about unconstrained and constrained optimization. I'm going to start with the cigars and brandy problem, which we looked at for homework. So, utility depends upon consumption of cigars and consumption of brandies. This is an unconstrained problem because there is no restriction placed on the possible values for C and B. We'll see constrained in a few moments. So let's go to the solution for this one. Here's our utility function, slightly distorted. Our choice variables are cigars and brandies. Our utility function is a function of this thing. So cigars is named C underscore. That's the name for the quantity there when we refer to it in the formula. B for brandies. Utility function implements this. If I double click on here, I can see 20 times C minus C squared plus 18 times B minus 3B squared. That is indeed the function. Let's go to solver, go to data, and solver, and I'm going to set the objective function equal to B6 by changing variable cells C and B. Now, I didn't type those names in there, I just did this. And if we go to solve that, we get a solution. Let's check the solution is good. Let's change this a little bit. Not much change there. Maybe I go to home and if we go back to 10, get a slightly better answer. Okay, so we could do that again and we'd find that in fact this is indeed the optimal solution. Okay, so let's go out to the constrained problem, and in order to do that I'm going to bring up this information. Wally's doctor gives him strict orders to cut back on his consumption of cigars and brandies. Says you can't consume more than 5 a day in an evening. So we're going to change this is now a constraint. 5 cigars and brandies is the maximum. Later on we'll change the constraint to 14 and see how that affects things. So let's go to the constraint sheet. All right. Oh, so first, before I go there, let me describe a couple things that we can see here. If I zoom out, I find some other things here. So let's make this normal width. Okay, so here's a picture of what's going on. Notice that utility is in the y-axis and cigars and brandies are respectively on this axis. Excuse me, utilities in the z-axis, the vertical, and then these two things in the plane here, X and Y axes, those are brandies and cigars. How did I make this picture? Well, the way I did it was to put the utility function into a sort of homemade table. Notice I named this range cigars. Okay, so if I go here, I can look at cigars. And I named the other range brandies. And then I had functions. So this one refers to cigars equal to 2, brandies equal to 1. Hit escape, go over here. This one refers to cigars equal to 7 and brandies equal to 3. Okay, so I got this whole table created using names and remembering that if I name a whole range, say I name this entire range, when I refer to cigars, I'm referring to, and in this row I'm referring to that level, in this row I'm referring to that level. Same with brandies. And then let's draw the picture. So the way to do that is to go to select everything. Select your entire table, including the upper left-hand corner, and go to Insert, go to Charts here, and what we're going to want to do is we're going to want to find a 3D chart. So not listed here, but we'll find it. Okay, so recommended all charts here. We're going to go to a surface chart. That's a surface. And that's what we want. Hit OK. Looks like this. Now you can actually take this chart and you can maneuver it. If you right click on it, we can do some 3D rotation and make it pretty. And let's see. I pick rotation. I can change this guy. If I make it go up, right, I can do the Y rotation. I can also do X rotation. And you can see that I can eventually get it looking kind of nice. All right, enough of that. So next, I also wanted to show you this. This is the Excel table solution to the problem, where I have a table, and notice that the function is a function of table. It's got B4 and B3, and this is a 2D table. We're tracking the value of B6 as we vary stuff in B3 and as we vary things in B4. Respectively, the row is B4, the column is B3. So the column is here, the row is here. Okay, and so what's B3? Well, this is cigars, and B4 is brandy. So B3 is the column, so this is brandies, and B4 is, excuse me, I may have got that messed up, but you get the picture. All right, let's move on to the constrained problem. Okay, so here's a picture of what's going on. What we've done is we've taken this 3D graph here. Let me get rid of the previous one. The 3D graph, and we've cut into it. All right, we're going to cut into it, and we're going to solve the constraint problem. And so we're going to pay attention to this graph. Notice here that well, let's go to this thing. So here's cigars, here's brandies, here's utility. Okay, and we're going to impose doctor's orders, and we're also going to have a question of whether we're meeting the constraint. So the constraint, well, that's doctor's orders, minus C plus B. So remember the order the doctor said. You cannot consume more than a total of 5 cigars and brandies. I don't care how you divide it up between cigars and brandies, you can't consume more than 5 of them. All right. How is that set up in terms of our solver? Well, utility is basically as it was before, right? But we're going to add in this constraint met thing. So let's see solver. Let's go to data and solver. Okay, so let's read it. We're going to set the objective function B6 equal to a maximum by changing cells B3 and B4. So that's what we had before. The new thing is that the constraint is going to be imposed. The constraint we have here is B9 has got to be greater than or equal to 0. Let's talk about that, and then I'll show you how to add a constraint in. So B9 greater than or equal to 0 means that the constraint has got to, well, let's take a look at what B9 is. Come back in a second. Constraint is, doctor says you can't consume more than 20. The amount of cigars and brandies you're consuming at the moment is 5. So you've more than met the constraint. Let's change this. Let's say the doctor's orders are 3. Now constraint met is minus 2, meaning that we have not met the constraint. The doctor says you can consume 3, but we're actually consuming a total of 5. So if we had 4 here, 4 for doctor's orders, we'd be closer to meeting the constraint. If we were at 5, we've exactly met the constraint. That's a number very close to 0. We're at 6, we're off. Okay, we met the constraint and more so. So consuming only 5. All right, let's go take a look. Let's run solve. Let's go back to solver here, and the constraint says you've got a max utility subject to the constraints that B9 has got to be greater than or equal to 0. Let's solve in this case. Doctor said 6. We're only consuming 5. What's going to happen? Oh, okay. So now what we're going to do is we're going to end up consuming 4.75 cigars, 1.25 brandies, and we exactly meet doctor's orders. We don't exceed 6. Notice, we're better off. We were consuming 5 before. Doctor says you can consume 6. We're better off. Great. All right, so that's the way the thing is done. Let's go back to solver. Oh, let's solve our problem here once again. If it's 5, we're not meeting the constraint. We got to cut back. Should we cut back? Let's hit solve. Let me go here. Okay, and by the way, this is a pretty severe constraint. We would like to maximize the utility, but we can't do it. Now let's go back and take a look at the unconstrained problem. We were consuming a total of 13. If we say 13 is doctor's orders, then we got a lot more possibilities and we can get further up to the top of the hill. Okay, so what we've done is previously we were sort of cut off and we could not get to the top of the hill. We were at a level of utility of not 79. Oh, we were at 79 before, but when we solve it, we can get all the way to 127. Okay. Let me show you how you add a constraint. Let's go to Solver, and let me delete this constraint and then go back and add it in. So if I add a constraint, I have to pick this cell, which is this one. Okay, that registers whether or not we're meeting doctor's orders, and you have to think a little bit about the logic of this. I'm going to go greater than or equal to 0. Okay, so the reason for that, let's hit close. The reason for that is, let's suppose we went to 11 for cigars, is that if we could overconsume, the constraint met value is going to be negative. If we're overconsuming, the constraint met value is going to be negative. The only time we know we've met the constraint is if constraint met is 0 or greater. So for example, here if the constraint is 13 and we said we'll do 3 cigars and 3 brandies, not a very good choice. We've definitely met the constraint. We're way under 13, we're only at 6, so we're 7 over the constraint. We're 7 under the constraint, and we think of that as a positive number in this case. You of course can set it the other way. If you made C plus B minus constraint, then this would be a minus 7, and we'd have to change the way we phrase this. We'd have B9 less than or equal to 0. Okay. Now let's talk about the graph. Right. So this is the same thing as before. Right. We've got cigars plus brandies. Right. But we have a little bit more complicated setup here. Rather than displaying the entire surface, we're going to display only the part that's unconstrained with a little bit of jaggedness here. But basically, we want to show, hey, the constraint it basically reduces our possibilities. Well, let's take a look at how this thing is done. The key thing is the formula. Right? The formula says if cigars plus brandy is less than or equal to constraint, then give me this result. Otherwise, give me nothing. If cigars and brandies is less than or equal to constraint, so we are following doctor's orders, then we display utility. Otherwise, we display nothing, which turns out is thought of as 0. And so you can see that, say with a constraint of 13, we could do 12 cigars and 1 brandy. We could do 11 cigars and 2 brandies. We could do 8 brandies and 5 cigars. Okay, so we have all these possibilities open to us. We certainly could go inside, but that'd be kind of crazy. We'd much rather be somewhere on the outside. In fact, we'd rather be here at 10 and 3. Change the constraint. Doctor's orders is, like, say, 6. Then we can only add up to 6 in terms of cigars and brandies. Much more constrained setup. Now notice it looks like a really tall thing here, but now the best we could do is 90. Okay, and so one thing, by the way, we've not included is the possibility of 0 for any of these guys, which we could easily put in. So 0 brandies, etc. Okay, that's it for now.